Hello everyone. In this lecture, we are going to see a brief introduction on these four topics. And firstly, coming to Arduino. Uh, what actually is the Arduino? Arduino is a microcontroller. In order to know what actually a microcontroller is, first you need to know the difference between a controller and a microcontroller. If you know the definition of controller, then automatically you will only able to define microcontroller. Controller is a hardware part which is present in the computer's CPU for the purpose of processing. In the same way, microcontroller is present on the Arduino boards. And yeah, now here you can see that a microcontroller contains one or more CPUs along with memory and programmable input or output peripherals. As all are integrated within the small in size, that is the reason it is known as microcontroller. And yeah, here you can see CPUs use controllers, and this is the microcontroller. And for Arduino, you know the microcontroller we are using is 80 MEL 80 Mega 328P. And in big computers, there will be direct processors. Here you can see the differences. And next, coming to yeah, Arduino microcontroller is introduced in during the year 2005 in order to build prototypes. For example, I am interested in designing a smart house. Directly, I can't work with a large house, right? Right, because if any damage happens, there will be a great loss in crores of money. So first, even in big industries, they build a prototype, and such prototypes or the small size products will be using the Arduino software and hardware part. And for that we are going to they have introduced the Arduino. And here you can see it is an open source, and it is a very easy microcontroller comparing to other microcontrollers. And the reasons why it is used is physical computing projects or research purpose, and for rapid prototyping it is used, as I mentioned with an example. And before going to understand about sensors and actuators, firstly you need to know about types of Arduinos. These are the some of the important types of Arduinos. Still there are many types. And coming to our complete project session, we are going to use Arduino Uno. And here mainly Arduino Uno and Arduino N are easily interactable with shields like Wi-Fi shield and Ethernet shield. It means that the data, nothing but the output which we are getting, is sent over cloud using those shieldings, also known as peripheral devices. And Arduino robot is used in building the miniature robots. And similarly, Leonardo is also a famous one, but this does not support USB connection. And coming to here, by seeing name itself, you can identify why Arduino Micro, Nano, Mini, and Mega differ. And coming to Mega, Mega is also used for some of the larger applications. Yeah, here you can see the differences. About Arduino, I am going to explain in the next slides. And here you can see Arduino Uno and Arduino Mega. What are the differences are? Arduino Leonardo was also supported, but it does not supported for Ethernet shield and Wi-Fi shields easily. It became too complex, so that most of the members prefer Arduino Uno. And coming to Arduino Mega, it is used for as I mentioned, some of the larger applications. So there are lots of digital pins and analog pins. And coming to next slide, yeah, this is what we are going to use in our all the experiments. This is the complete structure of Arduino Uno. This Arduino Uno consists of completely 14 digital pins. Those are numbered from 0 to 13. And here these are for in-circuit serial programming. And this is the microcontroller which controls the entire Arduino device. As I mentioned the name, here you can see 80 MEL 80 Mega 328 P microcontroller, and it consists of 6 analog pins A0 to A5, and this is the power supply and this is the power input. Actually, the power supply and power input, here the reasons are this power supply does not give power to Arduino. From Arduino, it delivers the power to the sensors and the actuators. And coming to here, the power input. This power input provides the power to Arduino board, complete board, and this USB port is connected to our CPU, or if we use laptops for USB port, we can connect it, and using that we can upload our code to it and reset button. Once we upload the code, uh, after when you close the software Arduino also and you remove the USB and again when you connect it, the application runs continuously because the code is saved in storage part, and if you click the reset button the code will be cleared. Now coming back to the difference between sensors and actuators are sensors are the devices, and on the devices the individual parts like lights, LEDs, motors, those are known as actuators. Uh, for example, let me consider a sensor, IR sensor. It consists of some LEDs and some of the lights. It consists of a LED which indicates the transmitter of IR rays, and these lights, it consists of two lights. One is the power light. As soon as power supply, it will glow, and one more is the obstacle light. So this is the difference between actuators and sensors. Sensors are the devices and the actuators are the parts which are present in the sensors for performing the result. And coming to still now what we have seen is the hardware part, but the programming, as you know that for Python there is IDLE, Colab, Jupyter Notebook. Similarly here we will have Arduino IDE. It is known as Integrated Development Environment. This is the icon of the Arduino IDE software tool, and the programming is similar to C++ programming. Yeah, Arduino IDE also supports the various packages similarly to Java Eclipse, where we require all the external libraries. Here similarly, but it integrates with the hardware. So for a single sensor, there will be multiple packages available based on the functions which we are going to use throughout our program. And about the installation and the basic programming in Arduino IDE, we are going to see in the next video. Yeah, for working with Arduino IDE, we must require the hardware tools. But if you want to know just basics and leave it, you can use the online editor, that is nothing but Tinkercad is the software. And in Tinkercad, you can design circuit and enter the program. There also it runs, but only for smaller applications like blinking LED, buzzer, IR, LDR sensors you can work with. But the real-time applications are not supported in the Tinkercad, and it's a free and open source. And after creating the account, go to circuits, and by clicking on create new circuits, thereby you will get a search toolbox. In the next slide it is present. Yeah, here you can see that search toolbox. From here you can enter what devices or the what hardware you require, and thereby you can get those here, and you can connect them using the what colors you want. It is similar to jumper wires, and hereby you can see code is present, right there. You need to enter the program, and once you click on the start simulation, it runs. And I am also going to demonstrate only one or two experiments in this online one, and remaining all we are going to work with the hardware parts only. Yes, that's all for this video. And in the next video, we are going to see how to install Arduino IDE and what requirements are present in that particular software. And in the other video, we are going to see about Tinkercad. And once these three videos are finished, we are going to start with the experiments to Arduino IDE itself. Thank you.